So in this video, we're going to talk about how to determine asymptotes and domain and range of rational functions. So a vertical asymptote will occur at an x value that the function approaches but does not actually cross. So you can see in this example, it has a vertical asymptote at x equals 0. A horizontal asymptote will occur at y values that the function approaches as x approaches positive and negative infinity. So you can see in this example that it has a horizontal asymptote at y equals 0. So you can determine horizontal asymptotes by looking at the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. If the degree of the numerator equals the degree of the denominator, the horizontal asymptote is y equals a over b, where a is the leading coefficient of the numerator, b is the leading coefficient of the denominator. If the degree of the numerator is bigger than the degree of the denominator, there is no horizontal asymptote. So we can also talk about the domain and range of rational functions. The domain of a rational function will be all real numbers except where there are wholes or vertical asymptotes. The range of a rational function will be all real numbers except where there are wholes or horizontal asymptotes. So we'll have to describe the domain and range in pieces so that we can leave out those values that are excluded. So here's how you find asymptotes and domain and range of rational functions. You always want to start off by factoring the numerator and denominator. Then you're going to identify any wholes, and then find any vertical asymptotes, find horizontal asymptotes, and then figure out the domain and range. So let's look at this example. We always want to start off by factoring. So we're going to factor the numerator, 2x squared minus 4x. Notice that there's a GCF. There's the GCF of 2x that I can factor out. So I have 2x times, and then I have 2x squared over 2x minus 4x over 2x. So when I simplify this, I have 2x times, 2 and 2 cancel, and then x squared over x is just x, minus 4 divided by 2 is 2, and then x and x cancel. So now let's go on and factor the denominator. So we have x cubed plus 3x squared plus 2x. So the GCF of these three terms is x. So I'm going to go ahead and factor it out. So I have x cubed over x plus 3x squared over x plus 2x over x. So when I factor that out, I have x times x cubed over x is x squared, plus 3, and then x squared over x, which is x, plus 2, and then the x and x cancel each other out. So now I need two factors of 2 that are going to add up to 3. Since 2 is positive and 3 is positive, I'm going to use both positive factors. The only factors of 2 are 1 and 2, and they do add up to 3. So the factored form of the denominator is going to be x times x plus 1 times x plus 2. So let's go ahead and write f of x in factored form. So we have f of x equals 2 times x minus 2 over x times x minus 1, x plus 1 times x plus 2. So now if we look at this, notice that we have that common factor of x, okay? So I'm going to pull that common factor out and set it equal to 0. So that tells me x equals 0. So I have a whole where x equals 0. I need to now figure out the y coordinate. So to do that, I'm going to plug into the simplified function that I get when I cancel this common factor. So I have 2 times x minus 2 over x plus 1 times x plus 2. So when I plug in 0, I get 2 times 0 minus 2 over 0 plus 1 times 0 plus 2. So that gives me 2 times 0 minus 2 is negative 2 over 1 times 2. So when I simplify this, that gives me negative 4 over 2, which equals negative 2. So the whole is going to occur at 0, negative 2. Okay, so I've figured out one piece of information so far. Now let's find the location of the asymptotes. Okay, so we have a vertical asymptote, and we also have maybe a horizontal asymptote. So let's go ahead and figure out where these occur. So for the vertical asymptote, you want to set the denominator equal to 0, but you want to leave out any of those factors that are common in the numerator and denominator, right? Because remember, the common factor, we're going to have a whole, so we're going to leave that out. Okay, so if I factor the denominator, remember that's going to be x times x plus 1 times x plus 2. But when I figure out the vertical asymptote, I'm going to exclude that factor that was common because that x was a whole. So when I set this equal to 0, that gives me x plus 1 equals 0, or x plus 2 equals 0. So when I solve these two equations, that gives me x equals negative 1, which is one of my vertical asymptotes, and x equals negative 2, which is another vertical asymptote. So for the horizontal asymptote, I'm going to look at the degree of the numerator and denominator. Okay, so the degree of the numerator is 2. The degree of the denominator is 3, right? The highest degree term. So we have 2 and we have 3. Well, in this case, the numerator degree is less than the degree of the denominator. So we have this situation right here. So that means there is a horizontal asymptote at y equals 0. So now that we have all of these pieces of information, we can figure out the domain and range, right? So we're going to say all real numbers except where we have holes or where we have asymptotes. Okay, so the domain is going to start off at negative infinity. So it's going to go from negative infinity. Okay, let's see. We have two holes, right? Two asymptotes. We have asymptotes at negative 2 and negative 1. Okay. Also, I'm going to go ahead and remind you of where our hole is. Okay, so the hole is at 0, negative 2. So you kind of want to think of these x values as a number line, okay? So we're going to go from smallest to biggest. So it's going to go from negative infinity to negative 2, right? Because that's the smallest value. And then it's going to stop there. Then it's going to go from negative 2 to the next value. So the next bigger x value, we have negative 1. Okay, and then it's going to go from there to the next value. We have negative 1, and then it's going to go to 0. Okay, so as this graph goes along, it's going to stop at all these points, and then it's going to start again. And then the final piece, it's going to go from 0 to infinity. Okay, so that's how we express that the graph goes all the way from negative infinity to positive infinity, but we have to break it up in all these little pieces to account for where it has holes or where it has vertical asymptotes. We're going to do the same thing with the range, okay? The range is going to go anywhere from negative infinity to positive infinity, but we're going to stop where we have an asymptote, right? So we have y equals 0, and we also have our hole at 0, negative 2. This time we're going to look at the y values. So we're going to go from the smallest y value to the biggest. So it's going to go from negative infinity to negative 2, then from negative 2 to 0, and then it's going to go from 0 to positive infinity. Okay, so these are all the pieces that make up the range of this function. So what you can do is you can confirm this by graphing the function in Desmos. Okay, so when you graph in Desmos, you can see that we have that hole at 0, negative 2 that we identified. And you can see that the domain does in fact go in 3 pieces, right? So you can see the different pieces here. And you can see that the range also has those different pieces just like we talked about. So now let's find the asymptotes, domain, and range of x squared minus 3x and graph the function. So what we're going to do is we're going to start off by factoring the numerator and denominator. Okay, so let's factor the numerator, x squared minus 3x. So the GCF is going to be x. So let's factor out an x. So we have x squared over x minus 3x over x. So that will become x times x squared over x will become x. And then minus, we have 3, and then x and x that cancel. Now let's go ahead and factor the denominator. Well, the denominator is already, it's prime, right? It's x minus 3, so we can't factor it. So we have x times x minus 3 over x minus 3. So now we can see that we have that common factor of x minus 3. So let's go ahead and set it equal to 0. And when we solve for x, we get x equals 3. Okay, so that's the location of our hole. So this simplified function, when I cancel the common factors, is going to be x. So when I plug in 3 for x, that's just going to be 3. Okay, so that means that my hole is going to occur at x equals 3 and at y equals 3, right? Because f of x equals x. So if you plug in f of 3, that's just going to tell you that equals 3. So the hole is going to be at 3, 3. So now let's identify the vertical and horizontal asymptotes. So the vertical asymptote, remember we set the denominator equal to 0. Well, the denominator, that is already x minus 3, right? So we're going to leave out anywhere we have a hole. So since there's no other like factors or terms in the denominator, we're just going to say there's no vertical asymptote. And let's figure out the horizontal asymptote. Well, the horizontal asymptote, we have to figure out the degree of the numerator and denominator. So the degree of the numerator, okay, you can see that's 2, and the degree of the denominator is 1. So when we think about the relationship, 2 is bigger than 1. So we have a situation where the degree of the numerator is bigger than the degree of the denominator. So there is actually going to be no horizontal asymptote either. So now let's talk about the domain and range. Okay, so for domain and range, we want to think about everything except where we have holes or asymptotes. Well, there are no asymptotes, right? But we do have that hole at 3, 3. So that is going to be the only value that we exclude from our domain and range. So the domain is going to go from negative infinity to 3 and from 3 to infinity, right? That's how we say all numbers except 3. And the range is going to do the same thing, negative infinity to 3 and 3 to infinity. Remember, you can always verify this by looking at the graph of the function. So let's go ahead and look at the graph. And you can see that it is it kind of looks like a line, and the reason for that is because that common factor, when it cancels, you're left with just f of x equals x. And you can see that it has that hole there at 3, 3. All right, so now let's find the asymptotes and the domain and range of this function. So once again, we're just going to start off by factoring. So I'm going to factor that denominator, x squared minus 6x minus 16. So we have negative 16. So since 16 is negative, we have a positive and a negative factor. Since 6 is negative, we're going to make the bigger factor negative. So we have 1 and 16, 2 and 8, and we have 4 and 4. So 1 and negative 16 is negative 15, 2 and negative 8 is negative 6. So that is going to be the correct set of factors. We have x plus 2 times x minus 8. So let's go ahead and write the factored form of this expression. So we have 1 over x plus 2 times x minus 8. Notice there are no common factors, so we have no holes in the graph of this function. Let's go ahead and figure out the vertical asymptotes. So for the vertical asymptote, we're going to set the denominator equal to 0 and solve for x. So we already factored the denominator, so we're going to say that's x minus 8 times x plus 2. And so we set each factor equal to 0 now, and we are going to solve for x. So we add 8 to both sides, so that tells us that x equals 8 is a vertical asymptote. Subtract 2 from both sides, which tells us that x equals negative 2 is a vertical asymptote. Now let's figure out the horizontal asymptote. Well, we need to know the degree of the numerator, right? Well, there's no x in the numerator. Remember, if there's no x, that's like there's an x equals x to the 0, right? Remember that x to the 0 equals 1. So the degree of the numerator is 0 because there's no x there. And the degree of the denominator is actually 2, okay? So the degree of the numerator is less than the degree of the denominator, so we would say that it has a horizontal asymptote at y equals 0. So that is our horizontal asymptote. So now let's think about the domain and range, okay? So we're going to include everything except where we have holes or asymptotes. So let's just go back and remind ourselves, okay, we have vertical asymptotes at x equals 8, and x equals negative 2. We have no holes in our function, so don't need to worry about that. And we have a horizontal asymptote at y equals 0. So the domain is going to go from negative infinity to negative 2. Then it's going to go from negative 2 to 8. And it's going to go from then 8 to infinity, right? So that includes everything except the 2 asymptotes that we described. Then the range is going to go everywhere except 0. So we're going to go negative infinity to 0 and 0 to infinity. Remember, when you graph the function, you can see that it's broken up into 3 pieces for the domain, and it has those 2 parts for the range as well. So now let's find the asymptotes and the domain and range of negative 2x over x cubed minus x. So we're going to always go ahead, start off by factoring. So the numerator, the negative 2x, I'm just going to write that as negative 2 times x. And then the x cubed minus x, notice that there's a GCF of x. So I'm going to factor out the x, and then I'm going to divide it out of both terms. So when I do that, I get x times x cubed over x is x squared minus x over x, which is 1. X squared minus 1, notice that that's a difference of 2 squares, right? So I can write that as x times x plus 1 times x minus 1. So let's go ahead and write the factored form of this expression. So we have 2 times x over x times x plus 1 times x minus 1. Okay, so notice that we have that common factor of x. So I'm going to set that equal to 0 to determine my whole. If I cancel both of these factors, I am left with negative 2 over x plus 1 times x minus 1. So when I plug in x equals 0, I get negative 2 over 0 plus 1 times 0 minus 1. So that gives us negative 2 over 1 times negative 1. So that's negative 2 over negative 1, which is 2. Okay, so the whole is going to occur at 0, 2. Okay, so that's the whole of our function. So now let's figure out the vertical and horizontal asymptotes. Okay, so vertical asymptote, horizontal asymptote. So the vertical asymptote, remember, we're going to factor the denominator, set it equal to 0, but we're going to leave out any factors that were in our whole, right? So we have x times x plus 1 times x minus 1, but we're going to leave out that factor of x because that's where we had a whole in the function. So we're just going to set each of these factors equal to 0. So when we do that, we end up with, here we have x equals negative 1. And then here we're going to add 1 to both sides. So that gives us x equals 1. Okay, so we have two vertical asymptotes. Horizontal asymptote, we need to compare the degree of the numerator and denominator. So the degree of the numerator here, that's going to be 1. The degree of the denominator is 3. Okay, so 1 is less than 3. So we have the situation where the degree of the numerator is less than the degree of the denominator. So we have y equals 0 as our horizontal asymptote. So now let's go ahead and figure out the domain and range. So we're going to include all values except where we have asymptotes or where we have wholes. So if we go back, remember we have a whole at 0, 2. Okay, so we're going to say the whole at 0, 2. And then we have our vertical asymptote at x equals negative 1 and at x equals 1. We have our horizontal asymptote at y equals 0. So we're going to use all of these values when describing the domain and range. Okay, so domain is going to go from negative infinity, and then the smallest x value we need to exclude is negative 1. So then it's going to go from negative 1, and then the next value we need to exclude is that x value of the whole, so that's 0. And then it's going to go from 0 to the next x value we need to exclude, which is 1. And then from 1, it's going to keep going all the way to positive infinity. Okay, so those are all the pieces of the domain of our function. Now let's think about the range. Okay, so for the range, we need to exclude 0, and we need to exclude 2. So we're going to go from negative infinity to 0, and then we're going to go from 0 to 2, and then we go from 2 all the way to positive infinity. Okay, so those are the three pieces of the range. Remember, you can always graph the function to verify what's going on. You can see there we have the whole at 0, 2. So now you can go ahead and pause the video and try this example on your own. So when you do this, you're going to factor the numerator and denominator. So when you do that, you'll see we have a common factor of x plus 3. So that means we'll have a whole at negative 3 and 2/5 for our y value. And so we're going to go ahead and determine the vertical and horizontal asymptotes. Remember, you're going to factor the denominator, but exclude this factor of plus 3 because that is where we have the whole. So that tells us we have a vertical asymptote at x equals 2. The degree of the numerator equals the degree of the denominator. So we do the ratio of the two leading coefficients, right? 2 over 1. That's how we get the horizontal asymptote at y equals 2. So now that we have the whole and the asymptotes, we're going to determine domain and range. So domain is going to exclude everything that is our whole, right? So we have the whole at negative 3, 2/5. So the negative 3 is going to be excluded, and also the value that's in the vertical asymptote, that x equals 2, is going to be excluded. So the domain goes from negative infinity to negative 3, then negative 3 to 2, and then from 2 to infinity. The range is going to go up to the value, that y value that's in the whole, so negative infinity to 2/5, and then 2/5 to 2, because remember, 2 was our horizontal asymptote, right? So we had our horizontal asymptote at y equals 2, and then it goes from 2 to infinity. Remember, you can always verify these by going ahead and graphing the function in Desmos and looking at the graph. So when you're describing rational functions, it's important to think about several key characteristics. You want to think about the domain and range, the asymptotes. So think about vertical and horizontal asymptotes, then identify any intercepts, and then think about the domain and range. Remember, domain and range will include all real numbers except values where the function has a hole or an asymptote.